I'm going to talk through a business case that we've been working on with Oxford University Endowment Management. Those who attended our last event in October will have already seen it in action. Andrew presented it. But basically, it's a tool that allows Oxford University Endowment Management to apply generative AI to their investment analysis. But what I'm going to talk about, I'm going to do a bit of a recap for people who weren't at the last session, and then I'm going to talk about how we have advanced it further since we presented that session. So as a quick recap, I'll introduce Oxford University Endowment Management, or OUEM, as I'll refer to them throughout, because the whole name of it is quite long to be saying over and over again. They're managers of charitable money, which are provided through the university through donations from former pupils and others as well. They currently manage over £6 billion in assets, and that's around equivalent to 10 billion Singapore dollars. They're doing pretty well. Over the last 10 years, they've returned approximately 8% annually. And we've worked with them for 15 years. Most of that has been designing and developing a quantitative system that's basically aiding their monitoring of their investments and they're using it to sort of inform decisions they're going to make in the future about where they're investing. They invest slightly differently compared to usual funds. Rarely do they ever invest directly in a company. Instead, they allocate their money to other agents, which are often other funds. And each of those funds is going to behave differently and make different decisions based on the market. OUEM also invests on a sort of much longer time horizon than your sort of typical funds. If you think about a pension fund, it's probably maximizing for the working life of someone. Oxford University has been around for centuries, plans to be around for centuries more. So they're investing on a sort of much longer term for people who will be attending the university who probably aren't even born yet. And that obviously affects the decisions that they're making in terms of the investments. The other thing is that approximately 25% of their assets are invested in technology. So they have a keen interest in terms of how they can use technology to make their analysts better and make them use their time more valuably. But they're also just interested in technology in terms of investing in it as well. So they're investing in these different funds, these different agents, and they want to be constantly asking questions and understanding how these agents are working. So they want to understand, say, what's the state of the market? And from the agent's perspective, how do they see the market's going to perform? What's the state of their portfolio? And basically, how has the fund been doing? And yes, they can ask these fund managers questions whenever they get in meetings with them, but also they will want that information at hand whenever they want it. And they have multiple data sources where they can get some of this information. One is the quantitative data model that I talked about. So we've been working with them for 15 years. They can get quantitative insights such as like raw performance numbers, exact details on the investments the funds have been making. But what that purely quantitative system isn't providing is any of the qualitative information that is actually provided to OUEM every quarter through quarterly investor reports provided by the fund manager. This qualitative information is incredibly valuable. It contains really key nuggets of information. But what they've been doing to try and sort of extract information from that is time consuming. They're just using their human analysts. So first of all, the human analysts are struggling to find the right report. They've actually accumulated over 10,000 reports since across all their investments and all the different funds. Secondly, by the time you find the right report, it could have 10 or 20 pages. You've got to read through it, go through the sort of executive summaries or whatever else, try and find that key nugget of information that they're looking for. And then third, there's just time going into surfacing that insight with the team. So yes, you can email the whole team, but also how do you make sure that you're sharing the right insight at the right time whenever someone's actually making a decision about that fund? So we worked with them to develop a tool that consolidated their reports and allowed analysts to basically index and enable querying on the unstructured data that's in these reports. By unstructured data, I basically just mean the text data that's contained within these documents. And that really amplifies the investment analyst's time so that they can focus on other areas where they can add even more value for the organization. And this is really just the first step we've taken with them. So whenever we started the project, we agreed a sort of long-term goal. We've done the first step of that, but we're moving towards a system where they'll be able to have an AI-based tool that's going to provide sort of answers based on qualitative and quantitative data. So we're working on both systems, but how does a user sort of ask one question and then get a sort of blended golden record that's going to give an answer based on all the information available. So I've talked about it a bit. Let me give a demo of it here. So this is the user interface that the Oxford University Endowment investment analyst will see. It's not the actual copy of it that's sitting in OUEM's environment. We obviously wouldn't show that. This is a carbon copy of it that we've built in our environment. The other thing that's slightly different is I mentioned OUEM invest in other funds. Those funds are often private funds. Their quarterly investment reports are private, so we're clearly not going to show those. What we've used instead is we've loaded in a number of different investor reports from other companies. We've actually done it across 4 domains, so technology, consumer goods, medtech, and mining. I've limited the domain to technology, so we're only going to be searching across the sort of technology documents. And just to show what one of those look like, this is just the NVIDIA 2024 annual report. So you can see it's got photos to try and sort of make it more appealing. It's got text in different places, quotes. It's all formatted slightly differently. If I kept going further down, I'd get to points where there's different tables and stuff. So it's not just a sort of text document, it's a PDF with different things that you need to sort through. And what we can do is we can search across those. I'll just drop this away to go full screen. So we can search across these documents, and we have different interfaces that the analysts can use. So they can go to document, where it's just got a list of the documents. But what I want to show you is the search interface and the chat interface. So what I can search here is climate. So if I'm an investment analyst, I'm interested in what, say, the funds or the companies I'm invested in are doing about climate change and taking any climate initiatives on. And what it's going to do is it's going to search, and it's not just doing a keyword search, it's more advanced than that. It's also picking up terms that are similar in meaning, so sort of semantically similar words or phrases as well. So you can see here with Apple, it's picked up climate change, but it's also picked up environmental, also picked up carbon neutral. You can see the one above, it's even picked up commercial scale seaweed farm, which I know James likes. And if I want to, then I can go in, and what it's going to bring me to is what's called a chunk, which is just a collection of 3 pages from the report, which means that I can find that pretty easily where it's talking about, there we go, supporting communities and protecting the environment. And if I'm James and I really want to read more about those commercial seaweed farms, I can go and see that final bullet point. You can see it's listed there. So that's great. We've got an advanced search. We can search for a term related to a question that we're trying to answer. But then we still only just get the full report, which we then have to read through, interpret ourselves, probably summarize when we're sending to our boss or a customer or someone else interested. So what is a slightly better interface is a chat interface where we can ask different questions as well. So I'll not go down the climate change route. Let me instead, since Trevor was talking about NVIDIA, give me a summary of NVIDIA's 2024 Q3 report. And I'll add a please, just in case it answers any better. So it's going to generate an answer. So it's doing the type of search, and then it's summarizing the response as well. So it's summarizing that key information. So you can see it's talking about the third quarter of fiscal 2024. It's talking about revenue values. It's talking about some of the other key pieces of information in that, giving an outlook, giving key highlights. What you'll also notice is the sort of little ones here as well. And that's because it's actually referring to a document and actually referring to a specific 3 pages in a document as well. And then if I want, I can click on that. It's going to open the document, and then I can read through and validate. We've been encouraging the analysts to, yes, trust the summaries, but also do just go and verify and just quickly read through that part of the document and just make sure that sort of it's making, particularly anywhere there's like a number, that you want to make sure it's giving the correct value. And then what it does as well is it can actually hold that context. So You can see here the second bullet point, it's talking about data center revenue. So I can say, tell me more about data center revenue. So you can see there, I've asked the question. It's then talking about data center revenue for NVIDIA. So it's keeping the context of NVIDIA. I haven't mentioned NVIDIA in the question. It's not in any of these filters as well, but it's keeping the context from the last piece of conversation. And it's giving me more detail basically on those data centers as well. And then again, I can ask another follow-on question if I want. So you can see the growth drivers. Growth in data centers revenue is attributed to the increasing demand of accelerated computing and AI technologies. So I can say, can you elaborate on the demand for AI technologies? If I can spell technologies correctly. And there you can see it's actually provided a bit of a summary around it. And what you can see is it's mentioning things like Azure OpenAI and stuff like that. So it's actually decided, okay, for the context, I'm going to go and search across a larger set of documents. I'm no longer just looking at NVIDIA. I'm looking at Microsoft, Alphabet, Alphabet's Google, obviously, to sort of find what they're saying around that demand for AI, because they're the ones using those chips from NVIDIA. And final point is, I've liked all the responses that I've got here, so I can provide that feedback. If I didn't like the feedback, we've enabled this for OUEM. They can then provide some feedback if the citation's wrong or if it's irrelevant or inaccurate, anything like that. We're logging every question that's asked, every answer that's given, and any feedback that's joined to that as well. So our team can make changes as needed if there's something that's going sort of consistently wrong. Okay, so OUEM's investment team, they're currently using that application, but while they've been doing that, we've been implementing changes to the platform. So I showed this slide at the start of the demo. It was our sort of general proposed progression, but as the AI markets advanced, we've actually added in a sort of another step for advancement. So when we built the application, we started with OpenAI's model in the solution. Why do we do that? It was basically the most or only viable option at the time. It was successful. We were able to apply generative AI to investment analysis. But now that open source technologies have advanced, what we wanted to do, and we realized would be really useful for the customer, is if we can make that foundation there more robust. So more robust, I mean, having from an operational perspective, more resilience. So not just relying on one provider, OpenAI and their models. Also from the commercial perspective, if you're not locked into OpenAI, then you're less susceptible to being locked into sort of model price increases. You saw from Trevor's slides that OpenAI are the ones that are probably charging the highest. So this was our immediate next step, still with that long-term goal in mind of moving towards qualitative and quantitative data together. To talk you through those changes that we made, I'm going to just cover quickly how the solution worked with OpenAI. So this is a retrieval augmented generation architecture, or RAG architecture. Going from left to right, you have thousands of investor reports stored in SharePoint in PDF format. All documents are brought together in one place, the Azure Data Lake. Then we use AI-powered tools to extract the information from them. So we use AI document intelligence to drag out the text, the different sections, the tables from the documents and the text into text files. Then we build the search index using Azure AI Search. And then the search index can be accessed via a search interface, as I showed, or a chat interface, as I showed, and that chat interface is powered by OpenAI's model. And then to break down the steps in terms of getting from the PDF documents to the search index, what we had to do was extract useful fields. So some of the sort of document attributes, like what company is it about, what year, what quarter is it for. So we extracted those first. We also then converted the plain text output from AI document intelligence, so whatever's stored in the reports, converted it into a text format called Markdown. It provides just a little bit more formatting that actually we found helps the model handle information, particularly the information in tables. We then also split the documents into 3-page chunks. And that basically allowed us to pass like more concentrated, shorter amounts of information into the model rather than a whole 20-page document, for example. So then we take those defining attributes, the markdown content, and we also create a vector content field, and we pass all those to the search index. The vector content field is to sort of basically take that chunk and create a value that's going to allow us to measure how similar the content of that is to some of the search terms that we're asking. Then what happens when we input a query? First, we create search terms based on the query itself. We then apply the filter if that's been chosen by the user. So if the user selects in the drop-down filters you saw in the chat interface, if they choose meta, for example, then it's only going to search across meta documents. We then apply a vector search and a keyword search together and bring them together. This hybrid search gives us flexibility when we want. So when we're searching on words like climate, it's able to provide words of similar meaning, but also we have quite a robust exactness keyword search whenever we're searching for terms like the company name. So like meta, you don't want to have similar meanings to the word meta because it's really just like the way you're classifying the document. If you're asking about meta, you want meta documents to be feeding in. From that hybrid search, we take the top 50 results. We then pass over those 50 with another search, more detailed search that you wouldn't do across all the documents. But because we've narrowed down to 50, we can do that. We re-rank them. Then we take the top 6 chunks and pass those to the model. Why 6? It was what worked best. We set it as a parameter. We changed the number around. We found that 6 was providing the sort of best detail to the investment analysts. So we send that input query. So the original input query, the chunks are combined with a system prompt, and all of that is passed to the model. Then the model then takes that relevant context in the question and provides a neat answer. To give an example of how we sort of pull that together or what it looks like, this is an example of the final prompt or the sort of composite prompt that gets sent to the model. So this is what it looks like. It's a combination of the system prompt. This is sent with every query that goes to the model. And it's basically telling the model how to behave. So you can see the first sentence there that I've bolded. You're basically telling it the persona. You're a financial expert that helps an endowment fund digest reports from their investments. So it's setting that instruction. It's also setting additional instructions in terms of how to interpret the data and how to format the output as well. Then we pass the top 6 chunks. It's actually a lot longer than this. There's a few ellipses in there, but you're passing all that information of like, what's the most relevant information based on the searches that we did. You're passing that to the model as well, along with the system prompt. And we're also including the original user query as well. So all of that is fed to the model. So when you're typing something in, it's not just that going to the large language model, it's that plus the system prompt plus all the context that we've searched across. And hopefully that gets across just that AI isn't just out of the box, great, you can use it and it's working perfectly. This actually required a fair amount of data engineering to build this prompt together so that you're asking the question the best way to get the best response. So I've talked really positively about how our application was brilliant and it's really working well and they're using it. So why change things? Why actually move to a modularized platform? Well, vendors have different offerings. You saw Trevor's section, that just number of different companies, particularly those large cloud companies, each have their own benefits and you want the ability to take advantage of any sort of new advancements that any vendor is going to bring out. You also want to avoid dependency and lock-in risks. So what if OpenAI raised the price of their offering? What if OpenAI is actually bought over by Elon Musk and he completely changes the pricing or he changes how it can be accessed? You can only access it if you've got a blue tick or something like that. It sounds far-fetched, but he did almost buy it. And also in November 2023, you saw a case where OpenAI was sort of quite rocky. It had internal political struggles. Sam Altman left the organization in one weekend and came back in the same weekend. So you are relying on a company that, inevitably stuff could happen to. So you want that flexibility. Performance and feature improvements. So AI has been the leader in the space. It's performed better than its open source equivalents generally. But the leader is going to be regularly changing hands. You saw there was the sort of DeepSeek shakeup when people were sort of saying, okay, is this model better than OpenAI? And you're going to have, like I said, different leaders at different points. Therefore, if you can build in a way that's going to allow you to really easily sub in the best model, then you don't really care who the leader is if you can just point to that model and use it instead within your existing system, even if that is putting OpenAI back in, if it sort of excels further as well. Final consideration is just access. Different companies have different constraints and sort of limit access at times. We know cases where a couple of companies have banned proprietary model APIs because the data is leaving their environment. Rules like that can't come in, they can be taken away. Having that flexibility just allows you to basically use whatever alternative is going to be best. So how does that improved solution work? This is the OpenAI architecture. This is what we transitioned to. So we replaced it in this case we replaced OpenAI's model with Llama 3.170B, but we did it in a way that would allow us to sub in multiple different models. This is just the one we used. We also used Databricks vector search instead of Azure AI search as our search index. We also added LangChain. That's the key framework that's going to orchestrate these components and allows us to plug in different models with relative ease. And the important thing is that it's not just Meta or OpenAI. The solution is built to work on whatever model is going to work best, whether it's an Azure offering, whether it's another proprietary model, whether it's open source alternatives. We should be able to adapt quickly as these new technologies and new models come out. And I will say that one click of a button and replacing these two things makes it look really easy. It's not. We had these two components to replace. It took a little bit of work to get that working using the tools we brought in. So I'll not talk through this in detail, but basically what it did take was considerable configuration and careful evaluation to ensure compatibility and basically reach the same operational readiness in line with the OpenAI solution. So it took a fair bit of work, but it was more customized and we added that flexibility. Just to give a bit of an example of what it was like replacing it and try and get it back to what we were getting with out of the box with OpenAI. This was whenever we first sort of plugged in the Llama model, the response we got. So you can see no citations, shorter than we really want, no formatting. So then we changed the system prompt. We got a bit of a longer response, but if anything, that just further showed how much we need the formatting. Still no citations. Then we got to a point where we were getting something of citations, but we had to move that on. There, we're getting the citations, a little bit of formatting, and then finally, we're getting a much more clean response, neatly formatted with citations as well. But it was constant iterations of development to get there. So to conclude this section, we have completed the evolution to an open source vendor-independent framework. We've set a good foundation that allows us to leverage open source or proprietary models, whatever is going to work best, or work best for the amount that OEM are willing to pay. The architecture provides flexibility and adaptability, enables us to integrate to the latest LLM or embedding models. Again, like I said, based on what's going to perform best, is there a new technological advance, what's going to provide the best return on investment. So if the cost is too high, but we can get another model that's going to work to sort of 95% of the ability for a fifth of the price, we're going to make that change. And then there's clear long-term benefits. So firstly, there's no tie into any single vendor. That improves your operational resilience, your commercial resilience, no longer subject to vendor lock-in. And secondly, you've sort of future-proof the setup. So we can now incorporate higher performing or better value models as they emerge, all with minimal disruption to the end user. And the thing I sort of want to close with is what we've then experienced is building the solution purely in OpenAI versus sort of a fully functioning solution with the ability to sub in different models. There's pros and cons to each, right? So the pro is with the sort of fully functioning swap-in model, you've more control over the customization of the solution. You can switch the most appropriate model at any time. The con is it does just take a little bit more development time to actually get there. OpenAI was a lot more features out of the box when we built them. We had to work a little to actually get the sort of same output from the switch-in different model version that we were creating.